Algebra 1, Unit 9, Exponents and Exponential Functions. In this concept, we're going to talk about using exponent properties. First thing I'd like to do is go through a quick refresher that you should have seen before. So first of all, in the top right, I have an example, 10 to the 9th power. In this example, 10 is my base and 9 is my exponent. So if I look down here at my first three examples, I see for the first one, my base is 7. For the second one, my base is 8. And for the third one, my base is 3. The exponents for each of these are just the number in the top right. So we have exponent of 3 for the first problem, 2 for the second problem, and 5 for the third. An exponent just means to write that base that many times. So this first problem here, 7 to the third, that means I'm going to write 7 3 times. So the expanded form is 7 times 7 times 7. For my other two examples, I have 8 times 8, since it's 8 to the second, and then I have 3 times itself 5 times, since my exponent is 5. And then if I solve these with a calculator, if I put in 7 times 7 times 7, or 8 times 8, I get 343, 64, and 243. The next example, same idea. My base is 4. My exponent is 0. So that means I don't have anything to write for my expanded form. And if I were to put 4 to the 0 in my calculator, I just get 1. So anything to the 0 power is 1. That's something we're going to learn in this concept. And then the next one, my base is x. My exponent is 2. My expanded form would be x times x. And to solve it, I just still get x squared. You really need to make sure for this concept that you have a calculator and you know how to enter exponents on your calculator. If you don't know how to use it, please make sure and ask your teacher. The vocabulary that we're going to need for this concept are base, the number or variable that's raised to a power, exponent, the number indicating how many times the base is multiplied by itself, exponential form or notation exponent properties, a term with an exponent, and evaluate, to find the value of the expression. Our goal in this concept is by the end of the lesson that we are going to be able to solve something crazy looking like this. The first property we're going to learn about is the product property. Product means multiply, so what we have whenever we've got common bases, so here I have x to the a times x to the b, I'm just going to add my exponents, a plus b. And the base stays the same. I still have x. In our first problem here, we're going to write this example in expanded form to show why it works. So we have x to the third times x to the fifth. X to the third just means put x times itself 3 times. X to the fifth just means put x times itself 5 times. So in total, if I add up all those x's, I have x to the 8th power, because I have 8 x's going on. That's the same thing as just doing 3 plus 5. I'm going to jump down to example 3. This is y to the third times y to the 9th. My bases are the same, they're both y, so I can just add my exponents together, and I get y to the 12th. You don't have to write it in the expanded form like we did in example 1. You can if you want to, though. Next, we're going to do problem 6. So I have base 5, that's going to stay the same, and I'm going to add my exponents together. My exponents are 7 and negative 4. If I add those together, I get 5 to the third, which I can go ahead and evaluate. I can put that in my calculator and get 125 for my final answer. The next example I want to look at is problem 8. Let's start with the fact that we have coefficients out front. We have a negative 2 and a 4. So we're going to start by multiplying them since it has a multiplication symbol here in the middle. So multiply negative 2 and 4, we get negative 8. And now we're going to look at our y's. We have y to the negative 3 times y to the 9. We're going to add those exponents. In our final answer, we get y to the negative 8, negative 8 y to the 6th. Okay, now what I want you to do is you are going to pause your video and you're going to work out examples 2, 4, 5, and 7, and then restart the video to see my answers. Here are the answers to the rest of the problems. If you have any questions about these, please ask your teacher. The next property we're going to learn is the quotient property. The next property we're going to talk about is the quotient property. Quotient means division. So in this example, we see that we have division going on. x to the a divided by x to the b. Anytime we're dividing common bases like this, we're going to subtract our exponents. So now we have x to the a minus b. Let's look at our first example here and see why this works. So in this example, I have x to the 9 over x to the 4. So if I expand x to the 9th, I have x written out 9 times. And on the bottom, I have x written out 4 times. So all I need to do in this situation is think about canceling out something from the top and the bottom. So I can cancel an x out from the top and the bottom. I can actually cancel out another one, and another one, and another one. And now I can't cancel any more out from the top and the bottom because I don't have any more left in the bottom. If you count these up, we are left with 5 x's. So that's why we get x to the 5th. You don't need to expand it each time. You just need to show this work right here. X to the 9 minus 4. All right, I'm going to work out examples 3, 5, and 7 with you, and then we'll pause the video and I'll have you work out the even examples on your own. Okay, so for example 3, the first thing you need to do is put a 1 right there. If we don't have an exponent, then we know that there's a 1. So now I can subtract my exponents, since I have division going on, and I have y to the 7 minus 1, which equals y to the 6th. For problem 5, we have coefficients out front. So the first thing we're going to need to do is actually divide those. If we cover up our x's here, we can see it says 27 divided by 3, and that gives me 9. And then I can take care of my x, negative 2 minus negative 5. So be careful there with all those minuses. Make sure you have negative 2 minus negative 5. Minus a negative is just a plus. So this is like negative 2 plus 5, which would give me an exponent of 3. And then for problem 7, it looks like I've got x to the 5 minus 1, and then I'll have y to the 1 minus 1, and then just z. There's no z on bottom. If I simplify those, I'm going to get x to the 4. My y is going to cancel out because it would be y to the 0, which is just 1, and then I still have the z left. So pause your video now, try the even examples, and then restart to see my answers. Here are the answers to the even problems. If you have questions about any of them, please make sure and ask your teacher. The next property we're going to talk about is the power to power property. So this is whenever we have a power raised to a power. So this is read x to the a to the b. Anytime we have a power to a power, we're going to multiply those two powers together. So you see we have x to the a times b. In this first example, we're going to talk about why this works. So if we have x to the 4th to the 3rd power, that's like writing x to the 4th out 3 times. X to the 4th, x to the 4th, x to the 4th. And then if I expand those, so 4x's, 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 and add up all those x's, I have 12 x's. So that's the same thing as just doing 4 times 3. I'm going to work through the examples 4, 6, and 8 with you, and then I'll leave 2, 3, 5, and 7 for you to do on your own in a minute. So for example 4, we have h to the 3rd times j to the 2nd, all to the 3rd power. So for h, we're going to put h to the 3rd times 3. And then for j, we have j squared, or j to the 2nd times 3. If I go ahead and multiply those together, my final answer is going to be h to the 9th, j to the 6th. For example 6, the first thing I'm going to do is look at the 3 that's out front and put an exponent of 1 on it. So remember, if we have something that doesn't have an exponent, we need to put a 1 there. So now I'm going to take the 3 that's outside that exponent, outside the parentheses, and I'm going to multiply each of the other exponents by 3. So we're going to have 3 to the 1 times 3, c to the 2 times 3, and d to the 6 times 3. And now we can go ahead and multiply those exponents. In our last step here, 3 to the 3rd, we don't want to leave it like that. So if we evaluate that in our calculator, we're going to get 27 for that coefficient. In example 8, I'm going to start by putting an exponent of 1 on both my 2 and my 3. And then I'm going to go ahead and multiply the exponents as I go here. So I'm going to have 2 to the 2nd, and then c to the 4th. I went ahead and multiplied 2 times 2. 3 to the 2nd, and d to the 6th. The last thing I need to do here is make sure I evaluate 2 squared and 3 squared. Okay, now I want you to pause your video and I want you to work out 2, 3, 5, and 7 and restart your video to see the answer. If you have any questions about these, please make sure you ask your teacher. The last property that we're going to learn about in this concept is the power of 0. Anything to the 0 power, it's always going to equal 1. I'm going to work out problems 1, 3, and 5 with you for this set of examples. So the first problem, y to the 0, that's just going to be 1. For the next one, I have y to the 0 again, so I'm going to replace that with 1. So I get 3 over 1, which just equals 3. For the next problem, I've got 12 over 3 to begin with, so 12 divided by 3 is 4. And then I have 5 x's on top and 1 x on bottom, so I'm going to need to subtract those exponents. So we get 4 in x to the 4th, since 5 minus 1 is 4. I don't need to put the z anymore because z to the 0 just became 1. I don't need to write times 1. Okay, pause the video and you work out examples 2, 4, and 6. If you have questions about any of these problems, please make sure and ask your teachers. Okay, after this lesson, you should be able to use the product property, the quotient property, the power to power property, and the power of 0 property.